this. All right, so that's good. So if you can't hear me or see me, just raise your hand electronically or send me a chat message so we can fix that. And so moving forward, our first lecture, our first topic of the lecture is literature search. Now you have already looked through how to get around the website. We have, so one new student looks like to me. Let's see if I can find. Hi, Sandy. She's still connecting. Let's make sure she can hear us. Hi, Sandy. How are you?
Hi.
Okay, good, good. You can hear me. So we just started. So this is our first slide. And for our topic that we want to write about, we need to do a thorough literature search. What does this mean? This means science progresses by publishing what they research on. And so other scientists read your work, and so that's where they learn what you're doing. And then they publish in turn based on what you have published. And so this is a snowball effect, and everybody teaches everybody, everybody learns from everybody else. And so as a community, we learn material and publish. So if you want to write an article, and which you want to, on say plastic pollution, then we need to figure out what is already published in this field. And in order to know what is already published in this field, we need to search the literature. This is what is called literature search, which means we're going to look for papers that have been already published by other people until now. And from those, we're going to pick a few articles and we're going to read them and understand, and then a few more, and then so on and so forth. We build a database of information and data and theory, concepts, etc., applications, and then use that information to write our manuscript. So literature search in any project, even if it is not a writing project, even in a lab project, is very, very important in science. Without this, we can't really do anything. So we ask even high school students to start learning how to do literature search. And then, only then we start the research project. So this is how things work. So why study this? And someone said writing is a true discovery. We discussed that in the previous class. So to begin writing, then we need to know what is already there. So that's the key part. And then we figure out what is already there. So that's the reason to do literature. Science practitioners publish their works in peer-reviewed journals, as I just mentioned, and or conferences or books and so on. And so if we read what is already there, then we can build on to new information, and new ideas and new experiments can come out of that. Most of the current and past literature are now electronically available. That's a really fun part for you guys. Because when I was starting doing the research, and it was really hard to find out what is already published. We had to go through what is called chemical abstracts service. And now also you have to go through chemical abstract service if you're doing chemistry research. But the difference is now it's all electronic. And so way back when, we had to do everything manually. In other words, we had to go through the books, huge volumes of literature, and then read this literature and then, come back. But now it is in a click of a mouse, you can get the article onto your desktop, and so you can read it much more easily. So what really changed is access. The access to information has become very fast and very efficient now when compared to even 10 years ago. And so it's not hard, but it adds layers of technology to it now. So we will go through some of those examples and how do you walk through the website and how to collect information you really need to. Now, the quality of information you collect is critical, right? If you have high quality information, then you can write a high quality article. If you don't have a high quality information, it's very difficult to write a good article. And so high quality information comes after you have done the search, very thorough. Very, very thorough search has to be done. And so there are many ways to do that. We'll go through them. So finding out what is already there, and this we also call it as prior art. Prior art is already published and out there, is not a simple task. And so one challenge is that the literature growing bigger and bigger every moment. So if you really want to keep track of plastic pollution, just such a small topic of the entire science, there are hundreds of publications coming out every year, hundreds. And so how many papers can you really read? Not very many. So you have to, figure out how we're going to, keep track of this and how challenging it is. But there are ways to simplify. We really don't have to read through all hundreds of articles. I will show you ways how you can collect information more efficiently than individual articles. Even the most established scientists, such as me, miss something, and because we cannot keep up with the literature. It's hard. So very soon we need a computer system that will read all the articles and tell us what's going on. So it's very similar to the medicine, what's happening, and the diseases and the drugs, and then the symptoms are so complex now. No physician can actually track all those things. So now there is this huge computer system called Watson, and that has all the information, and then it will tell the physician the diagnosis and diagnostics and the treatment and everything automatically in seconds. So we need something like that in science now. The situation has become that bad. So now in this lecture, we're going to discuss how you can access to this information. Now, there are multiple levels of searching, and I call it as the primary, secondary, and tertiary levels of search. And so primary level of search is, for example, Google. Right? You type in plastics pollution in Google, and it will come back with hundreds and hundreds of references. And it says, hey, it has been published here, and so on and so forth. Not everything you read on Google is real. And there's fake information, there's real information, there are publications, there are review articles, the popular science articles, and all kinds of things appear. But Google has this funny way of arranging the highest number of hits at the top and then lowest number of hits at the bottom. So this doesn't mean the highest number of hits is the high quality information. Just because a lot of people went there doesn't mean that's the best article in the world. So we have to keep track of that. We have to be careful about that and see how it works. So the articles at the highest frequency on the top, so look through them, read through them. I'm not saying you shouldn't, you should. And then take notes, write down keywords. This is what the primary level of searching is going to be, to collect keywords that are of interest to you. So for example, in plastics pollution, keyword could be ocean, plastics on the ocean, plastics in the water systems, or plastics on the land, plastic pollution, recycling, and not able to recycle, or accumulation or lethal effects of certain plastics on health, fish, and so on. So there are a lot of keywords that you can gather from Google search, topic search. And Google Scholar is a part of the search engine that is devoted for science. So I would suggest, instead of using general Google, go for Google Scholar search engine. It's more focused and gives you a lot of links to PDFs. So you can download them right away. It's actually very good machine, to a very good platform to do good quality search. So Google versus Google Scholar. Scholar is far better than Google itself for science searches. But there are other ways you can collect really authentic information. I will show you that in a minute. And Wikipedia is another good preliminary source. And I do this all the time. I go to Wikipedia to look for more details than at the Google level, right? So you do the Google search, you get hits, and then I go to Wikipedia on that particular topic. Like, for example, at enthalpy. And you go to Wikipedia on enthalpy. Is a nice website. It describes what is enthalpy, how it is measured, and so what is the state of the art, and all that sort of thing. But there is a word of caution about Wikipedia. Not everything in Wikipedia is correct. particularly about enthalpy, I have noticed there are mistakes made. And so you have to be aware of it. But there is a lot of useful information. Again, you can collect more keywords, and I will tell you why keywords are important in a minute. And so write down your keywords on your topic that you might use them later on, and get a general picture of the topic. What's happening, what is current, and what seems to be the real issue. Things like that. You can get an overall picture of the topic using Wikipedia. So it's my favorite place to go, even though there are issues and incorrect information there. And then you write a short report, so list your keywords. Sometimes definitions. We don't know how a particular thing is defined. What is a microplastic, for example, right? So I said in the last class, 5 mm or less in size, one of the 3 dimensions. So what if all 3 dimensions are 5 mm? So you can ask all these questions. But anyway, definitions are key, and we need to understand the vocabulary or the words of the language, right? You need to know the words of the language in order to know the grammar and write a sentence out of it. And so these are all different sources of information that provide you. So this is your preliminary level of a search. Google, Wikipedia, and then write an abstract, summarizing yourself all the things that you learned through this process. And don't spend more than a couple of hours doing this. That's all really you need to do on primary level of search. And once you have written your report, then it will guide you further into the next level. And so the secondary level of search. So the secondary level of search is really, really useful. As I said earlier, Google Scholar is a good one. And it gives you links to PDFs that are published maybe 5 years ago, 10 years ago. As long as there is no copyright, they can share with you. But a lot of literature has copyright, at least for 2 years since it's published. So you may not get all the new information in Google Scholar. And so, but you can go to SciFinder, and SciFinder is Science Finder. So it is a database run by Chemical Abstracts Service, part of American Chemical Society. And this is for mostly chemistry. But having said that, it has polymer chemistry, it has biochemistry, it has biophysics, engineering. It's a fairly diverse set of database. You can find almost everything that you want to know, physics, etc., mathematics, a lot of it, and not all of it, but a lot of it that is related to chemistry. And all that you can find in SciFinder. In a few minutes, I will show you how to do a search on SciFinder, and you will see what I mean. Another one that so university subscribes to SciFinder, and all of you can access SciFinder. Not too long ago, like even 10 years ago, only 2 people on the campus could access at any given time. So it was highly restrictive, and so you had to wait. And if you're lucky, you would get access to it, and that you had to be on campus to do that. But now the situation has changed, and all the students and faculty can access to SciFinder from anywhere. You can do it from your dorm room, or traveling, or from a beach. You can access to it, and so that's really cool. Really cool to access, and that's my lifeline. I always go to SciFinder before I do anything, really, these days, in terms of science. It gives me a really good feel for what's going on. Science Direct is another search engine that University of Connecticut subscribes to. And it's also a good search engine. It covers lots of journals and access to them, etc. So that's really good as well, but I don't use it. Just, explore, see what you like to do. Scopus, PubMed, Medline, all these are different databases, different engines, and the University of Connecticut subscribes to most of these. So you'll have access to all of them. But the degree of access may differ and point of access may differ. But we will focus on SciFinder as our most important engine to get the literature search. Okay, so any questions thus far? So, okay, So a couple of levels of search, and then we're going to do first Google search, go to Wikipedia, then go to SciFinder, for example. Let's say that is our route, okay? So now you ended up with SciFinder. What do you do? So by the time you come to SciFinder, you already have a list of keywords, list of topics that you are interested in, and you may not learn all of them, about everything about all of them, but you're going to distill it down. So literature search is like a funnel. You start with a very broad, keywords, very broad topics, and as you start reading more and more, you actually concentrate, it's coming down to a very, very fine aspect of the literature that you're really interested in, that you're going to write your 15 pages on in this course. And so quickly you want to narrow it down. So how do you do that? How do you start broad and then how do you narrow it? I'll show you now. And so SciFinder, as I said, is a database that you can, search engine come database that you can subscribe to. And some of you may not have used this before. So I have decided I will get some screenshots to show you how to install it on your system. So if you're a new user, you have to install it on your system. So go to this website. This is guides.lib.uconn.edu. So in other words, just Google it. So I'm a new user, how do I install SciFinder on my system? And it will take you there. It will give you this link, and then you click on it, you go to the university library. The Babbage library holds all these things. So it's on the library website. And so here you can see UConn library, and then library guides, and then databases A to Z. So all the databases you can access through this process, through this link. Now, instead of all different databases, we're only interested in SciFinder. And I know, as a fact matter, that the service provider is American Chemical Society. So here, this tab here, I chose American Chemical Society as the provider of the service. So that makes things simpler, but you can also click on S here. That will also take you all the listing of word databases start with S. And so then you can also fish out from there. But this is easy because there are only two hits here. One is SciFinder Scholar. That's once you are registered yourself, you could use that. But first-time users, go here, SciFinder Scholar, registration for the first-time users. So you click on this link and you follow the messages on the screen. It's fairly easy. In about 5 minutes, you can register. All you need is your UConn ID and password that you already set up. And with that, you make a bookmark. And then next time onwards, you use that bookmark to go straight into SciFinder Scholar. Okay, so and so once you have registered, and then you want to log in. So this is the login screen. So once you have installed on your system SciFinder, you click on that, or use a link through the web. You can do both ways. I use the link on the web, and then it loads this page and then tells me to put in my credentials to log in. And so you do that. It's fairly simple and instructions. And once you have logged in to a system, our now goal is how we're going to use this. It's kind of sometimes a little intimidating. It comes up with a welcome screen and all that. So I'm not showing the welcome screen, but what I'm going to show you is basically what do you see on your open screen. So you have several tabs in the top here, and Explore is one of the tabs, and saved searches. If you were to use it before, you saved some of them, you can go back and look at them again. So that's a good feature, because you may be in the middle of something and you search something really interesting, but you didn't have time to finish it. And so you save that search, and you can come back another time and then go back and then continue the search and so on. And I never use SciPlanner, but I would like the class to explore this tab and tell the class what you can do with it. Now, under Explore, once you click on Explore, it gives you this drop-down menu. This is a drop-down menu. Item 1 on the menu subtopic is research topic, author name, company name, document identifier, journal, patent, tags. So you can different ways you can search the database. There are also chemical structure and other, I don't know what that is, but there are many ways. It's a substance tag. So somebody named something as a tag there, and so you can get into that. So you can draw a structure and then feed the structure, and then it will search that for you. So it's really cool. I don't do that, but when you need the information about a substance, right? About a substance, then you would do that. Let's say you want to know boiling point of benzene. Of course, you can Google it, but something more complicated than that, can't find in Google. You can come here and then draw a structure, and it will tell you its history, almost everything since 1900s. Everything you need to know, it will show you. But of course, you don't want to go through everything. What I've done then, I've chose research topic. Once you do that, it comes up with this little screen, okay? And this screen says references research topic. What that means is now I'm able to search the publications under this given research topic. And I haven't typed anything. Here's a little box here, and I can type in plastics pollution, for example. And there's some examples given here how to do it. And then you press the search button, and you can do advanced search where you can Boolean combination and all that sort of thing. I will let you explore all that. Okay. Once you type in your search keyword, this is why we need the keyword. So if you have multiple keywords, you can put them all in. It will search for all of them and come back to you with all the literature on those keywords. This is why keywords are really important. Definitions are important. And so you can now start to figure out how I'm going to do the search most efficiently. So the most efficient search is the best keyword. That will give you everything you need to know. But usually that's not the case. You have to use 2-3 different keywords in order to get all the information. So once you put that in and start the search, then the screen changes and you get something like this. So you still have SciFinder and all that. You still have those tabs up there. And now under references, it will give you, in this case, I used research topic, plastics pollution. That's exactly what I typed. And he came back and said to me, there are 2 responses here. There are topic candidates. So what does that mean? It means that there are 91 references that has this plastics pollution as entered. So somewhere in that document, that 2 words appeared together, plastics pollution. And so it pulled them out. Only 91 of them have that. And to me, that's the most important. And that's what I'm going to look for. But that doesn't cover everything. Now there is underneath that, there are about 12,000 references. That has the general concept, plastics pollution. What that means is plastics is one part, pollution is a different part. It may have plastics pollution together, or it may have different locations. And you have all these kind of combinations and so on and so forth. But at the moment, I'm not that much excited about that. And so I'm going to choose this. So if I click on here, then this button gets highlighted. So there's a little square here in front of 91 references. This gets activated, and then when I press on it, you get the next screen. So now it picked those references, 91 of them. And out of those 91, it's displaying only 76. So you can ask, why is that? That's because it has removed 15 duplicates. So the system has preferences. So you can go into the preferences and set up that the system filters out duplicates. And so it automatically can do that for you. So why you want to duplicate, right? So 15 duplicates out of 91. So you have 76 unique references it has come up. And it will give you all the 76 here. So first reference is here, then second, third, fourth. What I do before I go in further is to refine it. So there are 3 buttons here under references: analyze, refine, categorize. So what I normally do is refine, and then refine by language, because I know I cannot read anything else other than English really well. And so I choose everything written in English. And so this way, out of 76, maybe there are only 58 English documents. If you can read another language, you can choose so. It's not a problem. So choose whatever language you want to read the reference for. And then it will filter and then show you the remaining ones. Okay. Then second thing, I haven't done that here. I just showing what you could do. The other thing you can do is you can refine in terms of type of document, review article, journal article, newspaper article, abstracts like this. So you can filter those out as well and choose whatever you want. You can also choose based on the year. So you can say, well, I want to know everything from 2020 onwards. Only 2 years, that's enough for me because there's so much stuff in 2 years. And then if I need, I will go back and so on and so on. So you can, so the refine is a really, really good function they put in. And most of the time works really well. So you can refine your search and get the segment of references that has this. So let's say this is your reference or other references that below this you're interested in. How do you know that? How do you know this is interesting to you? So what this does, it gives you the title of the publication. And remember the keyword is there. So title of the publication, the life cycle of micro nano plastics in domestic sewage. So this is very fairly narrow in terms of source or where they found is a sewage. And then also fairly narrow because they're looking at the micro nanoplastics. And that's the title of the article. And here the authors, these are the people who published it. And it is published in this journal, Science of the Total Environment. Now, we have to understand that not all publications we can access to. But the library provides a really a good service where you can get a large number of different journals online or PDFs or borrow. And so don't be restricted by that. So don't worry about, where it is published right away. If you can't access it, then that's going to be an issue. And so that's it. And then underneath this is a quick view. And that's basically what the paper is and so on and so forth. Same as this, what you have seen, but not very different. But when you click on this, other sources, then you can access to the PDF, okay? Because, yeah, you read this and say, oh, yeah, this is interesting to me. A novel pollutant, microplastics, nanoplastics have been commonly found in all regions of the world. So then I say, oh, wow, this is really cool. Let me go find if I can find that article, right? Because I want to read all of it. It shows you plastics pollution quite nicely and so on. So it's a relevant article. Like this, there are several articles listed here, 76 of them. And you can go one by one and pick which ones you want. But before you do all that, I want to show you a couple more tricks. And so if you look in the top here, save, remember, once you do a search, you can save it. So you don't have to search it again next time when you come back in. You can print on a printer that if you have an access to it, or you can export. This is my favorite button. So what I normally do is good search, I refine it the way I want it. And then once I have all of them, before I go do anything else, I won't export them. So I can get it offline on my system and I can read it some of the day or some of the time and I'll manipulate it, do whatever I want to do with it. And so export is really nice, cool way of starting to process, okay? Starting to process your information that you have collected. So let's explore other sources versus export. These are two things we're going to explore further. But before we move on, there is an interesting number here. So what this number is, this is number of times this article has been cited by other workers. Let me close this window. It's a little noisy here. Just there we go. And so, so we'll explore that in the next slide. And so if you were to press on the export button, this is the screen you will see. Well, what is this showing me? It is showing me that, how to export into Word. It is a very nice way you can export all those references that you've seen, 76 of them, into a Word document. And then I can sit down, make a PDF, read them leisurely offline, right? So sometimes my website is too slow or whatever reason, So I always almost save as an export as a PDF or as a Word document in this case. So under export, there are several categories. I will go through this in some detail. So I choose all. You can do selected. Let's say out of 76 papers, you may have selected 5 of them. That's okay. After reading through them, you say, no, I only need this file, I don't need everything. But I would say just save everything. You can read carefully later on with a big font and whatever, and with comfort, and with your favorite beverage, and then decide which ones are interesting to you. But anyway, so you could choose any of these, and you can have a range 2 to 20. So for example, out of 76, that can be done. And you can also download them in terms of some specific uh, further manipulating software packages. And the citation manager is one of them, and that will further process the information. So you could put them this way, this way, this way for that particular application. I don't, I just want to have offline review. That's my focus in all of these guys. And so I can do it as a portable document format, as a PDF, but that's not very convenient for me because I want the Word format, so I can cut, paste, move things and do other things, write notes, etc. right on top of it. So I choose rich text format. So some of you may not know what this means. It's actually a text file, basically, a very low level Word file, and then Word can read this and convert that into a doc file. So not to worry about that, and they don't have a directly doc file. A rich text format has all the information in terms of fonts and special characters and all that stuff. So when you save it, you get everything as they should. And answer keys is more limited, and saving locally and all that you can also explore and see whether that makes any sense to you. Then in terms of details, file name. I usually give my own file name because I want to be able to retrieve that file later on. And so I say plastics pollution 2021, for example. So that way I know that file has all the information I need about plastics pollution of year 2021, or search done in 2021, whichever way you want to save them in a way you want. And then you have to tell it what format. And I want summary with all abstracts. So that's what I want, like the one I showed you, exact ditto, I want that. So that is summary with abstracts. You can have detailed full record. It takes so much long, it puts lots of unnecessary information, and you don't want that. Summary with partial abstracts is not much useful. Summary without abstracts, not at all useful. So all kinds of things on choices are there. I choose this, but you can choose whatever you want. And then press export. And then it will save you locally on your system. Okay. So as I said, now it's RTF file. You can read it using any text editor. Word will open it for you, and you'll be on the right track from there onwards. Okay, so that's how. Now, so how to get a PDF? Sometimes I want a PDF article. So in other words, I saved all my stuff. I come back and say, look, I find this particular article very interesting. So I want to get a PDF of this article right now. Okay, let's say I decided that. So here, that's a reference number 2 of 76. Sustainable bioplastics from amyloid fibril biodegradable polymer blends. Okay, so this interesting story. People are doing all kinds of stuff, and amyloid fibrils, and so these cause amyloid. They cause Alzheimer's and other things. I have no idea why they want to use amyloid fibrils for this. They're actually known to be toxic, and they can actually cause harm. If once it gets into somebody's bloodstream, it can really mess up the blood proteins and so on and so forth. I have no idea. This is a dangerous game, I think. That's my view. But you need to figure this out yourself. You can read and see what are these and so on. And it has a nice cartoon showing how you can recycle and how it can be used for storing vegetables. But I wouldn't touch anything that has amyloid fibril, even with a 10-foot pole. But anyways, as an example, ACS Sustainable Chemistry and Engineering, this is a journal published in 2021. This is the volume number. This is the page number. These are the people who published it, and so on. So if I press on the other sources, okay, then I can get a PDF out of that. So PDF of what? PDF of this article published in this journal, okay, which has this abstract on it. That's what I'm looking for. Means I want to read more in depth than just this abstract, because I've decided this is really interesting. I want to read it, okay? And so the next slide this is what usually it goes to the journal web page, and then you see the article. You ask it, okay, I want to download a PDF, and lets you do it. And it's all you can figure that out. But sometimes you don't. You don't have a PDF available right away. Whatever reason, copyright reason, we don't subscribe that journal to some remote journal that we don't have in our database, etc. At UConn. Then it has this option, UConn full text. So this is actually quite nice. And you can, if you click on this, then it gives you a nice little form. You just fill out with your email, and it will find that article for you and then send it to you within 24 hours. This is one of the best things at UConn, I can tell you. I mean, it's free, it's fast, it's accurate. And you can get a full copy of an article from almost any journal you want. And they're spending a fortune on this, I know that. But it's cheaper than subscribing to all those journals. And so this is trade-off. But then you have to wait for 24 hours. Usually you get less than that. In a few hours you get it. But sometimes it may take longer. So you get a full PDF of the article that has been published and so on and so forth. It's a really cool service from the David Library. Way back when I told the librarian, the chief librarian, that this is the way to go. You cannot buy every single book and put on your shelf. You get us a PDF of it. It'll work out to be cheaper and easier for us. Because these days, all the information is electronic to begin with. It's published electronically and so on. So getting a print copy is hard and expensive, and you need space to put the print copy. And then somebody has to walk all the way to the library and locate it and take the Xerox copy of it. Who is going to do that? Nobody does that anymore. So I was right. I said this almost 20 years ago, and the librarian was very upset that I said it. He said, "Oh, I'm a custodian of all the books." Yeah, well, you can have all the books you want, but people will stop reading paper copies. You have to go electronic sooner or later. And then very quickly after that, Google started scanning out the books. So Google Book Project came out, and they started scanning the books and make electronic copies available within 6 months. So anyway, things change and people have to change and then adapt. But the great thing is UConn embraced this idea. And so the library actually provides you really good source of all the kind of PDFs that you really need. So this is all I wanted to say, I think, about SciFinder. So this is how you work around